Now, section 9.5 is something called the dot product. Now, product we know is multiplication, and dot they use so that you don't think of foiling. So, for instance, when I say in number 1, I want to multiply v times w, when you see what we call a binomial, two things and two things, a lot of students think, oh, I'm just going to FOIL them together. So that's not actually the case. When you find a dot product of two vectors, you're actually going to multiply their horizontal components. So if you look up in the box here, the horizontal components of the two vectors, then you're going to multiply the vertical components of the two vectors, and then you add those numbers together. So it's not foiling here. So you're going to do the two things together and the two things together, then add the finals. So your final answer for dot products is actually a number with no i's and j's. Okay, so let's take a look at one. If I look at number 1a, find v dot w. So if I take the horizontal from v, the horizontal from w, then I add it to the vertical of v and the vertical of w, then I get 10 minus 9, I get a nice little 1. Okay, so it is not foiling. Okay, so you guys try part B, the w dot w. So just if you need to, you can write w twice or however it helps you. Now what we're going to do is we're going to take a look at a couple vectors, and we want to find the angle between them. So this is going to be helpful for if we want to see if they're parallel or perpendicular in a minute. So the first one says, find the angle between u and v. So let's draw these as neatly as we can here. So u is 1, 2, 3, 4 on the horizontals, 1, 2, 3, 4 on the horizontals, negative 3 on the j's, and then here's my vector u. Okay, and let's do the same thing with v. Let's build it nicely. 2 on the horizontals, positive 5 on the verticals. Here's my v. Now, at first glance, you're kind of looking at it. It could be 90, right? Kind of looks like it could be 90, but you don't know for sure until you actually do all the trig that goes along with it. So if I do it individually for u and v, okay, so let's just kind of build our triangles. Let's call one alpha and one beta here. Let's call alpha up here. We'll call beta down here. Okay, so if I want to find beta, I'm going to say tan beta is 3 over 4. Okay, now remember I'm going to do inverse tan on my calculator, so I get beta to be 37 degrees. Okay, now if I do the same thing for the other one, I go tan alpha is 5 over 2, and then make sure inverse tan on a calculator, I get 68 degrees. Okay, now if I want the angle between them, I'm talking about the angle in between the two vectors. So now I need to go an alpha plus beta, add them together, and I get 105 degrees. So when I say find the angle between the two vectors, it would be 105. Okay? Now, I want to do the second example as well because it's a little bit different. So if I build the same thing, all right, so these are going to overlap a little bit. I'm going to try to be nice and neat. I'm going to go 1, 2, 3 on the i's, 1, 2, 3, 4 on the j's. Okay, so here's v. And if I do the same thing with w, it goes over 1 and up 3, so it's like this, just barely out there. Okay, now when I build my triangle, take a look what happens. There's my w, here's my v, and the angle between them is a little sliver in here. So instead of doing alpha plus beta, I'm going to end up doing alpha minus beta on this one. Okay, so let's take a look. So let's do v first. So tan alpha equals 4 over 3, and I get my alpha to be 53 degrees. Same thing with beta. Tan beta is 3 over 4, and I get beta to be 37 degrees. Now remember, alpha minus beta this time, since there's a little sliver in between them, and I end up with 16 degrees. So again, sometimes they overlap like that, and sometimes they're separate, like in number 2. Okay, now the reason we want to find the angle between them is to tell if they are parallel or perpendicular. Now, when you're talking about vectors, there is a kind of a fancy word for perpendicular. It's orthogonal, all right? But if you were to write perpendicular on a quiz or test, that's fine. No worries there. Okay, so vectors are parallel if the angle between them is 0 or pi, because remember, pi is like 180. So let's take a picture of what that might look like. Okay, so let's say I have a vector going this way, v, and then I have a vector, and the angle between the two is 0. Well, that just means that the other vector is right on top of it. Okay, so if the angle between them is 0, we say they're parallel. Now, if the angle between them is pi, it means there's 180 degrees between them, so it would be going like that. So if I call W going this way, then W and V are also parallel. All right, and then the perpendicular thing probably also makes sense. Okay, so if I have V going this way, and the definition says the angle between them is pi over 2. Well, pi over 2 is 90, isn't it? So that means if it's pi over 2 between, then I call them perpendicular. Okay, so let's take a look. Parallel, orthogonal, or neither. Remember, you can say perpendicular. That's perfectly fine. So if I draw V, 1I, 1J, okay, V is going this way. Now, anytime you see a 1, 1, hopefully you're thinking 45, 45, 90. So let me go ahead and write that in. Okay, and then W is negative 1, 1. So W is going this way. And again, that one's a 45, 45, 90. So if I say parallel, orthogonal, or neither, we should say orthogonal for that one. All right, another quick example of that one. So V, 3 I's, 1, 2, 3. 1, 2, 3, 4, negative 4 on the J's. There's V. And I do the same thing with W, 4 I's, negative 3 J's. So that's going to be down here. And I say parallel, orthogonal, or neither, even without any math, we should be able to say that, oh, that one's neither. So you don't need to show a whole lot of work for these. All right, I'm going to do one more example here, and then the other word problems I'm going to leave for class. Okay, so the first one, we're talking about work. Now, you've done this in physics, where work is, this is in the box as well, but let's write it out here. Work is force times distance. Okay, so our typical question looks like number 5. A girl is pulling a wagon with a force of 50 pounds. Now, when we're pulling a wagon like this, we're actually pulling up on the handle of the wagon. We're not actually like pushing it or anything like that. So the 50 pounds, that's going to go on the hypotenuse. Okay? And we want to know how much work is done in moving it 100 feet. Now, I'm going to draw my 100 out this way, and I'll explain that in a minute. But 100 feet is the distance I want to move this thing. Okay? And this wagon makes a 30-degree angle with the ground, so 30 degrees. So now what I'm going to do is I'm going to kind of stop my red triangle like this. And what I want to talk about is this formula. Work is force times distance. If the distance is horizontal like this one, then I need to find the force that's horizontal like this one. So I'm going to put a red X on my triangle. So when I'm trying to find the force, I want the horizontal force on the triangle so it matches the horizontal distance. Okay? Now, to find the horizontal force, just go back to your SOHCAHTOA. Cosine 30 is x over 50. So 50 cosine 30 is your x, or your horizontal force, your force horizontal, however you want to write it, okay? Now, if the problem says find me work, and we say work is force times distance, well, the horizontal force is 50 cosine 30. Whoops, 30. And the distance I want to move it is 100 feet. Okay, crank that through my calculator. I actually left it as a root 3 since it's 30, 60, 90, but the decimal form would be fine too. So if I leave it as it is, it'll be 2500 root 3. Okay, all right, leave all the rest of the word problems blank for me.